is a video recording about the area of circles, and so it's going to start with a little side conversation about something that we're covering in class, or that we covered in class. How are the circumference and diameter of circles related? So we want to just make sure that we're really clear on this answer, because I know sometimes it's hard to follow along, and for those of you who weren't here in class, I think this will be important. So we just need to talk first about the parts of a circle. So the radius is half of a diameter. So I could just as well label the radius going out from my center of my circle. It's another important point of a circle. And a radius is any point, or the length of the circle from any point on the perimeter to the center. So the radius is effectively half of the diameter, or we could say the diameter equals 2 radiuses. Or we could say the radius equals 1/2 of the diameter. And these relationships are important to know. The circumference we found in class equals approximately, well, not approximately, I guess we could say approximately 3 times the diameter. You did a lot of measuring, and each time you found the circumference of a circle was about 3 times bigger than the diameter of that circle. And it turns out that it's about 3 times, but it's exactly pi times the diameter. And this is where pi comes from. Pi is equal to, it's a ratio. It's equal to the circumference divided by diameters. That's how it was discovered, as this relationship. Oh my gosh, how is it always that every time we look at the relationship between the circumference of a circle and its diameter, and we divide these numbers, we get the same number, 3.1415, something. It goes on forever. It's an irrational number that just continues on. And mathematicians are still finding new numbers, and I'm not sure what value they've gotten up to at this point of proving the decimals exactly. But anyways, pi is the relationship of the circumference divided by the diameter. And we can also think about it as the circumference being pi times the diameter. So these values are really important for you to know, and hopefully you have them written down somewhere and placed in your toolkit safely. When we're thinking about these values, it'll be helpful because we're going to start thinking about this question of whether or not we can make circles into rectangles. So you guys hypothesized that most shapes can be formed into rectangles, but a lot of you said not circles. And in class, you had this experience of taking segments of a circle, equal segments from these fraction pies, and trying to form rectangles. And it turns out you can actually get pretty close to making rectangles, even with these size pieces that we have to work with. And if I took a smaller size piece, like here I've got 12ths in my pie, the smaller the pieces, the more closely it resembles a rectangle. And so it turns out if we cut our circle up into tiny, tiny little segments or slices of that circle, we can effectively remove this curve on the outside, and it becomes almost like a rectangle whose area would be able to be calculated, or a parallelogram whose area would be able to be calculated with base times height. So then the question is, well, what would the base be if we spread it out? If I took a circle and I cut it in half, well, what's half of the circumference? I know the circumference is pi times the diameter, and I know that the diameter is made up of 2 radiuses. So half of a circumference could be labeled as pi times the radius. And then this half would be pi times the radius. And pi times the radius plus pi times the radius would still just be pi times a diameter. So 2 pi r equals, oh, I'm sorry, not 2 pi r, pi r plus pi r. I guess, would that be 2 pi r?